Before I start the video, I would like to say thank you to Beckhoff Japan and IFM Japan because they lent the device to me. In this video, the Beckhoff IPC C6920 is brought from Beckhoff Japan, and the Ethercat IOLINK master AL1332 is brought from IFM Japan. I really want to say thanks for you.
Hello, nice to see you again. I'm Fritz. In this video, I'll show you how to use Beckhoff IPC C6920 and IFM AL1332 to configure Ethercat network and let the TwinCAT, which is my Beckhoff IPC, to receive the IOLINK data from IFM AL1332, but also some digital signal, and I will then control the digital output. I hope you like my videos. Let's start. This is the conversions of my video in this time. You can see here is the Beckhoff IPC, and here is the IFM Ethercat IOLINK master AL1332, and 3 ports are using. The first port is used as a IOLINK port. It's connected to a keyence IOLINK sensor in here, and the second port and the second port is configured as a digital input, and the third port is configured as a digital output, and all this is connected to a ESTOP from Pilz. The port 2 is the digital input, so we receive the signal of the ESTOP, and the port 3 will trigger the LED lamp of the Pilz ESTOP. Okay, now we can shift how the program and make the conversions all between the Beckhoff IPC and the IFM 1332.
Okay, now is the time for us to configure our TwinCAT project. Now, first of all, because in this video tutorial we are using IFM AL1332, it is a Ethercat IOLINK master, so it is better that you download the ESI file from IFM. Okay, it's not difficult. You just go to Google and search AL1332 IFM, and then you can find out this page, and then slow down, go to format and description file, then you can download the ESI file Ethercat from here. It is zip file, just unzip it and save it some place. But don't worry, I'll also place this link in the end of my video. Okay, after you download the ESI file from IFM website, the next step is you need to import this ESI file into your TwinCAT IDE. It's very easy. Just go to C or the drive that you install the TwinCAT software, TwinCAT 3.1, config IO and Ethercat, and just play all the file inside this folder. After that, you can restart the TwinCAT or go to here, TwinCAT and Ethercat device, and below device descriptions. That's all. Okay, now I will add a Ethercat master first. Just let me to connect to my Beckhoff PLC. Go System, choose, and this is my Beckhoff IPC. We'll put OK, and now you see my TwinCAT is connected to the Beckhoff IPC. Then go to IO and device, right click, add new items, and choose Ethercat and Ethercat master. That's OK. Then from this IPC, there's 2 interfaces for me to make the Ethercat network. For example, choose this one and open the device one, the Ethercat master, and in the adapter tab you can find out the interface you're choosing is correct or not. But in here, I see my selection is wrong. Let's go search, choose the other one. Okay, this one is my Ethercat interface. So what is my next step? Let's go to right click, add new items, and go to IFM because you reload the ES file in the previous step. IFM IOLINK master, and IFM IOLINK master AL1332. This is the module we are using in this time. Press OK. Done. Now the data, the IOLINK master ESTOP IOLINK master is inserted in your project. Then here in default, all the 8 port module 1 to 8 is mean the port 1 to port 8 is all configured as a IOLINK port with 4 byte input and 4 byte output. We can configure it in any time. In any time. Just go to box 1, go slots. Then here it has a configuration of each port. Here is call it as slots. For example, in this our configuration, we configure the port 1 as a IOLINK port, then port 2 as a digital input port, and the port 3 as a digital output port. It's very easy. Okay, for the first one port, because in this video we are using the keyence IOLINK sensor, it only receives 2 bytes of distance from that device, so we don't need 4 bytes. No, just need 4 bytes input. How we do it? Just click channel 1 and click the X button to delete the configuration of channel 1, and then select IOL in 4 bytes and then insert again. Done. And for channel 2, it is a digital input, right? Just delete it and choose digital input. The first port is digital output. Okay, now the configuration is done, and you see here. Go see here, and now the module 1 is IOLINK within 4 bytes. The module 2 is a digital input, and the module 3 is digital output. It means the port 1, port 2 properly, or these 3 ports are configured properly. Okay, now here the TwinCAT network is complex. Okay, now we can add our PLC. Go to PLC, right click, add new items, and select the single PLC project, add. Now the PLC project is add, and go to the ports, main. Here is the program you run here, but before that I would like to define some user data type. It's not must, but it's my style. Yeah, you don't need to follow my rules. Let's go right click and add DUT. So there's 4 options when you create a data unit type. In this time I'll create a data unit type called neutron. What's that? So I will explain it after I created keyence ENC device VICS. Done. Okay, and as I told you before, this keyence sensor will receive 2 bytes of data, so I will use array of byte, and then I go the data int integer. So what does that mean? It means if you define a user data type as a neutron, it means these variables and this variable are both have same memory offset. So when you write when you write number 1 in data, so in here the byte 0 1 will be FA value 1, and also if you write all 0 in here, then here data will also be 0. It means they have the same data offset. If you change this type of value of this variable will also be changed because they are also actually have the same memory. Done. Okay, so and then we can define some data here. As I said before, the first port of the is the IOLINK port, right? Just so I'll say IFM port 1 is as a keyence device. Okay, and the port 2 is the input, right? Port 2 Q. I will say Q. Why? Oh, sorry. Because maybe you need to see the menu to see actually what happened. But if you open the IFM IOLINK master AL1332 and you go to a object called TXPDO IOLINK port codifier, then here you have 8 variables is a codifier of each port or each channel. So, and in the channel, and if you see the menu, in this it is a USID, is a byte data, it's 1 byte data. In the bit 1, it will show you the pin between 2 is now the signal is true or false, and also other bit also have their own meaning. For example, if error or not, pin voice status, and the value is okay or not. They have some data some state flag that you can take the operation data from that port. So it's a USID, right? Okay, just USID done. Okay, and the port 3 is the output. So just go to here. You can say RX video and go to here. You just go. All you need to do is just write 1 to this data. Then it will be automatic. They will be turn on the output. So what you need to do, just click here to confirm the data type is USID, and click IFM port 3. Port 3 is okay, right? Then USID done. But that's not enough, because now we need to map these 3 variables to the process IO. What we need to do, I do it so many times. We need some difficult declarations. Add %I snap mark. It is the process input. Do the same one as here. Oops, this is port 3. This is port 3 is okay. And here is Q. No. I write because I will need to write some value in here. Okay, then make this all here to be clearly done. Save it and make some program. Okay, I have a buffer called data int, and it will get the data from the port 1, the keyence IOLINK sensor. IFM is equal to data is equal to IFM port 1 dot data, and if IFM port 2Q dot the second bit, so it's dot 1, then I write a port 3 port 3 is equal to 1. Let's write very here, and then else I will write a 0 to turn off that output. Good. Oh, sorry. Equal. Okay, our program is done. Very easy, not difficult things. So go to build it. Make sure no error, because now returning any variables between our PLC and the Ethercat network. Okay, don't worry, we now fix it now. First of all, go to the channel 1. Channel 1 here, okay, and open it. Just select by 0 and by 1. Right click, change multiple link, and select the wrap date, the variables that you define in the user program. Good. And then the second we would like to define is the codifier. Just go to TXPDO IOLINK port codifier and select channel 2. Right click and choose the USID. Yeah, this one, port 2. Yes, okay, done. And the port 3 is the output, so we go to module 3 and browse it and select the first byte, right click, change link, and select port 3. Is this available? Is this one? And change it. Okay, done. Save it. So it seems like everything is ready, so we can activate the conversions. Okay, do you would like to reset the TwinCAT? Yes. Okay, just 1 second, the TwinCAT is resetting. Oh, done. The TwinCAT is reset, and download all our program into the RPLC and press start. Good. Now I see some values in here, and don't worry, I will turn on the video, turn on the camera, and show you actually the IFM module is working properly or not. Now I turn on the camera, then you see here is my TwinCAT PLC. It's all screen, no error, and here is the IFM Ethercat IOLINK master module. Just give me a second. And now you see the RJ45. The connector is LED is flashing. It means the Ethercat package is transferring between the Beckhoff IPC and the IFM device. Okay, the first of all I will show you the status of the ESTOP. It's a very cute ESTOP from Pilz. Thanks, they give me this one. This very cute. I feel like this ESTOP. When I press it, and now it's plus. So here you see the output is 0. So when I release it, now I feel like this one really. Now the LED is turning on because now I'm writing one in here, and the bit 1 is turning on. When I press the ESTOP again, now the bit 1 of the port 2 is changed to 0, and the output also be 0. Let's show you again. Good. Okay. Now the next one, I'll check the IOLINK sensor from keyence. Okay, you can see here. Here's the IOLINK sensor. Actually, the data is receiving from the IFM sensor from the IOLINK module, but you see the value is not exactly different. Why? Over here we see it's 400 something, but here it's minus 20,000 something. It's because it's a very common error between the European and American PLC and Japanese PLC because their byte sequence is different. So I fix it now, don't worry. Let's log out, and I define one more variable in here. Here go to here and underscore temp data port 1, and do the same one keyence device. Okay, and then I just do some tricky things here. What I do is I will check temp data port dot run data 0 is equal to IFM port dot dot run data the data index 1, and copy paste the same things. Here is will be 0. Okay. Oh right. Here it will be 0, and the RAM state will be 1. And finally, I will data. So data is not will be directly from IOLINK port 1 data. This will be anymore. It will be from the temp dot data. Done. Okay, so log in again. See what happened. Let me see. Let me check again. Open the camera. Okay. Why? First one is equal to 0. It should. Oh, okay. It works. Oh, sorry. I see. Okay, I see the wrong things. Let's see, sorry. And okay, let me open the here again, and go to here. Then you can see now the value is 400 something. Actually, the data is also 400 something, right? And I just repeat up. Go to my Windows side to see. that's 1100 something. Here so 1100 something, and upside is around also some 1000 something. Okay, the data is also can be saved from this nice ESI keyence IOLINK sensor. So actually what I done in here is I just shift swap the device 0 to byte 1 and byte to byte 0 to fix the byte subsequent problems. It's not some tricky things, but it's just some experience. Okay, my video is end. I hope you like this one. If you like my video, please subscribe my channel and give me a like, and I'll see you next time. Thank you. Bye bye.